Yes, guys, anyone can respond to this. That were you able to do it or not?
No, ma'am.
I did first one count. Okay. Kishan, are you talking about just a minute. Stair count, so I only told, na? Stair count was the problem which I discussed in the class, right? You executed it on your own. Okay, that's also well and good. Another questions tried, but no luck. Okay, fine. So here we'll see. I told you that you have been given a six-sided dice. You have been given a n, which is basically the sum. And you need to find out how many number of ways you can roll a dice to get the sum equals to n, right? This was the problem statement. Yes. And I also explained that if let's suppose I is the sum you have to reach, so you can either come from I minus 1 at stage, 2 at stage, I minus 3 at stage, and like similarly 6 stages, right? And if you expand it further, you will get that this particular problem has an overlapping subproblems. Clear till now? Yes. Okay. Anyone having any questions so far? No. So if you understand that DP exists, DP can be applied to this problem and overlapping subproblems exist. So our first step to this should be to find out the DP state. So what will be the DP state here?
Ma'am, I'm thinking dp I minus 1 plus dp I minus 2 until
Sorry, no. That is DP expression. I want to know DP state.
dpi. Um,
Mm-hmm.
so where I is 7, which is like number of ways to reach 7th.
I'm not getting you, Vishnu, and there is certain kind of disturbance from your end if you are turning on your mic.
Oh, okay. So what I'm saying is, like just how we have done in the past, I see that DPI is the way how we got for the previous problem of climbing stairs. It's the same thing here also,
Mm-hmm. Then?
DP. And then DP expression would be,
No,
um,
I want to know what should be the DP state. Just tell me that. Not similar to the staircase. Obviously, there should be something different. This is a separate question, right? Okay, I'll explain. So DP state is basically, let's suppose I am writing here DP of I. I need to find the I sum. So it will be number of ways to get sum equals to I or sum of I. Clear? Now you guys know that if you are, so I'll write the DP expression now. So if you have to reach the ith stage, you know that you have to consider all the previous 6 stages. That is summation of I equals to 1 till it will run till 6. And it should be dp of I minus, let me place it as j, dp of I minus j. And keep this in mind that whenever you are subtracting, let's suppose your I was 4, okay? And you reach j equals to 5. So when you will do 4 minus 5, it will be a negative value. So you should always keep in mind that I minus j should always be greater than or equals to 0. It should not be less than 0. Clear? Yes. Any doubts in this?
Ma'am, the summation should be until 7. So instead of 6, I thought.
Why 7? Can you tell me why you were thinking as 7?
Oh, okay. Now I'm clear. Like there'll be no chance when 0 will come for J. So yeah, so I'm clear now. It'll always vary from 1 to 6.
No, but 1 to 6 is fine, but you were going from 0 to 7, right?
Yeah.
But why?
Uh, the summation should be equal to or 7.
Why 7?
Oh,
You have
n
a dice
completed.
of 6 sides. 6
Yeah.
sides have the number as 1, 2, 3, 4, 5, 6. So why 7? 7 doesn't even exist in the dice.
Okay. Okay.
And this n which is given in front of you, it is just an example.
Yeah. It could be n.
It could be any number.
Mm.
Okay,
Yes. Got it.
perfect. So I guess if you guys are clear, then you can quickly tell me the base condition. Base condition will be Vishnu, I'm okay. I less than or equals to 0 returns 0. Perfect. If I is equals to 0, how many ways is there to get the sum equals to 0? One way, right? So you should define dp of 0 is equals to 1. Other than this, everything will be taken care by this particular dp expression. Clear? No, Vishnu, base condition should not be sum equal n, because at some point you can see this is a top-down approach we are following. Okay, if you are at n, then you are reaching at n minus 1, then n minus 2, then n minus 3, then you are moving further down, and this is going till you are reaching at a point where you need to stop. So base condition should be where you need to stop. Okay. And if base condition is clear, then next is table space. What is the table space you are going to use here? You are using the sum of previous 6 stages for every DP state, right? So that means you're storing it in some of the DP table, which is having the size n plus 1. Talking about space complexity, again, it's gonna be order of n. Talking about your, did we talk about time complexity? No, right? What is the time complexity? What is the time complexity? Order of n, 6 into n. It's basically linear. 6 is a constant, so order of n only I'll take. Okay, and next is, can there a space optimization possible? Yeah, tell me, space optimization is possible or not? Will be difficult, I think. We're reusing the variable. Guys, it is dependent on 6 previous stages. Is it dependent on stages before those 6 states? No, right? If you are counting dp of I, you only have to go till dp of I minus 6. After that, what are the answer? You doesn't even care, right? So if it is about only 6 states, instead of creating the dp table of n plus 1 size, you can create a dp table of only 7 size. That is, 0 will be something of your base condition. Then from 1 till 6, you have to maintain your 6 states, and whatever current you will be calculating, you will be storing like accordingly. Getting it?
So you
And
mean to say that as we move down, we will reuse the previous variable?
yeah, and what our answer will be, we won't be storing it as dp of I. It will be rather whatever your I. Just a minute. You will be reusing your space by using mod 7. And here also, whatever dp of I minus j is, na, do the mod 7 in that also. And in that way, your answer will be calculated. Space complexity, space optimization, yes. Time complexity, order of n, true. Space complexity now will become order of 1. Is it clear now?
Ma'am, I'm not clear with the mod of 7. So how was
Okay,
this?
see this. Uh, you have this dp table. You have 0 for sorry, not 0. Here you have 0, 1, 2, 3, 4, 5, and 6. Okay, now for 0, the number of ways is 1. For 1, the number of ways is just 1. Okay, are you getting it? For 2, the number of ways are going to be, either you find out 1, 1, or you get 2 directly. So number of ways is 2. For this 3, you can get 1, 1, 1. You can get 1, 2. You can get 2, 1, or you can directly get 3. So number of ways is 4. Right. And next for 4, sum of all the previous numbers, that is 6, 7, 8. For this, it's and I guess here it's gonna be 32. Okay. So this is what we find out. After this, if you have to find dp of 7, let's suppose your n was equals to 7 and you need to find for that. Then 7 is dependent on, I'll show you. 7 will be dependent on 6, 5, 4, 3, 2, and 1. Will it be dependent on 0 anymore? It is only dependent on previous 6 stages, right? Are you guys getting it? So there is no need for this 0 anymore, right? It's there or not there, you doesn't care. Clear? So what we do, if you have to find dp of 7, we do dp of whatever your n is or I is, that is 7, modulus 7, it gives you 0. So in dp of 0, you will store the sum of all these numbers. And all these numbers, I mean to say, you can add them all, whatever it is, 32 plus 16 is 48, 48 plus 8 is 56, 60, 62, 63. So 63 will come. 63 you will be storing at dp of 0. Are you getting this, Vishnu, now?
Yeah.
Basically, we are reusing our space. Instead of creating a new space here and storing the 7th value over here, I'm just reusing the space which is not needed anymore. Clear?
Yes, ma'am.
Yes, okay. Okay then, so if this is clear, then I guess we are good to go from this question. Next is this cost association. Can you do this on your own? That you have been given the cost of like whenever you roll a dice and you get certain number, you will be associated a cost with that, and you need to find the minimum cost at which you can get your sum. Can try. Okay, others, what about you?
So by cost, I could not understand what's the
Yesterday
cost.
we discussed this, right? That whenever you're rolling a dice, you will be charged a cost. Do you remember this?
No.
Were you there in the class yesterday?
Yeah, I was there.
Then why don't you remember this?
Oh, okay. Probably I was like sick. I was down.
Okay, no issues. It's basically like that there can be multiple ways you are rolling a dice. But the thing is, in those ways, you need to find just one way in which you are charged the minimum cost and you are getting your sum equals to n. Okay, like it is the same question as the dice roll, which I just explained. It's just that every time you are rolling a dice and you are getting some way, you will be charged some cost with it. Is it clear?
Yes.
Yeah. So that is the question, and that basically comes under the category of optimal substructure. Basically a category where you can have number of ways to solve a problem, but you only pick up that way where you are like getting charged the minimum or maximum doesn't matter. Just it's like only one way you have to take in that case. Clear? So I'll just quickly write down the expression for it.
Ma'am, could you just revise what is this overlapping SOS on the right side? Or is it not required right now?
Overlapping subproblem, optimal substructure, DP state, DP expression, base condition, time complexity, table space, space complexity, your answer where it belongs to, and space optimization.
Okay, okay, got it.
And I'll quickly write down the expression, like first the DP state and then the DP expression. And the remaining, I guess you guys can take it from there because it's like almost the same to the previous problem. So here, your DP state is going to be minimum cost to get minimum cost spent to get sum equals to I. And the DP expression is going to be, you have to find out for all the same, j equals to 1 till 6. And here you need to find, like every time you are getting some answer, you need to find the minimum of it. DP of I minus j plus there will be a cost associated with that j, right? So you need to add that up. Clear, guys? Okay,
Ma'am,
so
can you
this,
please repeat this again equation? How
it
it's
is
going to be?
written, right?
Uh, okay, just like the previous one.
It is not just like the previous one. In the previous one, you were just adding DP of I minus j every time,
Yeah.
right? In this DP of I minus j, whatever it is, you are adding your current cost of rolling the dice.
Okay. Okay.
Clear?
Yeah. And that we are doing minus min.
And
What
one
is
more thing, that you have one way to roll a dice to get sum equals to 0. But here, to get sum equals to 0, what will be the minimum cost? Any ideas, anyone? What is the minimum cost to get sum equals to 0?
3?
Why 3?
Um, like if I see below this here, put cost 3, then cost 8. Just let me zoom
Have
in.
I kept anything for 0?
No.
No. So if you don't know the cost, just simply put it as 0.
Okay.
This is your base condition for this program. Clear, guys? Okay. This question I'm not going to explain. This is something you have to try. I have already made you do 3 problems almost, or 4 problems so far. So I guess you can take this out or at least search for it. So I'm not going to explain this. If any doubts, you can come to me freely. No issues in that.
Ma'am, what is this floor problem?
Floor prob.
Yeah, to the left.
I think you guys made some group, right? Hello.
Yeah, I had. Oh,
Please discuss that in there, okay? Or otherwise discuss this at the end. Otherwise, the class is getting extended a little bit. Okay. Yeah. So our next question is, you have been given an array of n numbers. You have to find out the maximum subarray sum. I am not going to explain here what is a subarray. Those who know, can you tell me how to find the maximum subarray sum? Anyone in the class? Can you tell me how you can find the subarray?
We'll group them from left to right, different
Yeah,
combinations, different combinations like 4, 4 and minus 1, 4, minus 1, 7.
correct. So in amongst all the subarrays, you need to tell me which is a subarray which has the maximum sum. Question is clear?
Yeah.
What is the time complexity to solve that? What is the complexity to find out a subarray or find out subarrays of an?
Like the trivial way it is O(n) square, like uh, starting to the left, going all the way till the end.
Mhm. Okay. Can you implement that solution? Can you guys implement that solution?
So our goal is to generate maximum sum with all the positive numbers. I mean, I can just bypass all the negative numbers and then.
No, why? In subarray, you can't bypass any number. You have to go through that number.
So we can filter out because only positive number gives highest sum.
Okay. So if two negatives are there in a, sorry, my bad. I was thinking of multiplication. Yeah, correct.
Yeah, so that way, like the
Basically, my question is if you guys can implement the subarray sum or not. That's it. Yes, you can. Right. Okay. So if I tell you the time complexity of this particular problem, it's like if you like don't, if you try to find out the maximum complexity is n cube comma 1. In the case you are not just like calculating the subarrays on the go. N square is a case where you are on the go calculating your subarrays. Up to here, you guys can do it. I need not explain that. But can we have a lesser complexity than this for this problem? And there comes DP into picture. Okay, so if you look at this problem closely, you won't find any similar subproblems. Okay, but the thing is, the things are getting repeated over here. How? Looking this into a way of DP is, just a minute, guys. Okay, so here is that you have to find out, let's suppose, maximum subarray till like for this up to 0. What is the maximum subarray sum till 0?
4,
4. What is the maximum subarray sum from 0 till 1?
3.
Then similarly, you can continue up to 14, right? Yes or no? Yes. And then you can find out what is the maximum subarray sum you got so far amongst all these. Yes or no?
Yeah, store it in a temp variable.
Basically, why to store? Yeah, you can store it in a temp variable, or like currently you can say X. Then you calculate this. If you got the maximum, you replace it. If you didn't, you just move ahead. Then calculate it. Then again, if you got the maximum, update your variable. Otherwise, move ahead. And similarly, you have to keep doing it until you reach the end. Yes or no? Yes. Now, what about the subarrays from -1 till 15? You can get the get the answer or the maximum answer from that also. Yes or no? What will you do in that case? Just by removing index 0. But how? Okay. Think for this a little more. I'm giving you 2 minutes of time and then tell me the final answer. Did anyone figured out anything?
Ma'am, if there is a negative number, we can safely ignore it.
Correct.
So,
So my thing is, with what I'm trying to explain here is, okay, just see. What is the maximum subarray sum when you are at 0th index? Okay, that is 4, right? The maximum subarray sum when you are at 1. What it is going to be? Right now, your maximum sum is 4. What should be your next maximum sum? 4, right? Like even if you include 0 and 1, the maximum subarray amongst them, like the maximum sum you're going to get out of this is 4, right? So 4 you will carry on. With 7, what you're going to get? 11. Just a minute, sorry. Here 3 will come. With -15, with -15, it's -4. With 8, no. If you are carrying forward your answer and at some point your current element is bigger than your previous negative element, in that case, just ignore that particular element and keep your current element as it is, that is 8. Because keeping 8 in your subarray gives you more maximum answer as compared to adding -4 to your current number, right? Yes. Now with 3, it's 11. With -4, 7, 2, 9, 6, 15, 15 minus 1, 14, 14 plus 4, 18, 18 minus 20, it's -2, Again, when you will add it, it's like your value will be decreasing. So you will keep 8, then 9, and 9 plus 15, you're going to get 24, right? Now you will calculate the maximum amongst all of them. You are going to get 24, and that is your answer. Clear? So what we are doing, we are not finding out here every subarray. What we are doing, wherever we are getting some negative value or the value which is decreasing of a maximum sum, we are just leaving it there itself, and we are continuing from the different subarray. Clear? Yes or no? Yes.
Ma'am,
Anyone have?
I have a
Yeah.
small doubt. The subarray, can it skip 1 and 3 index, or it has to
Sorry.
be, can the um, subarray skip elements
No.
which is, no, it has to be,
Subarray can never skip elements. Otherwise, it is not a subarray. Then it become a subset or subsequence, you can say.
oh, okay.
Okay.
Yeah.
So if you guys understood the working of it, this is a very famous algorithm, which we call as in Kadani's algorithm. Okay. And basically the DP state which we are using here is, as we calculated, you guys must have guessed it. It says that you have to find the max subarray sum. I should write DP of I is equals to max subarray sum till I or till ith index, including I. That means at that point you have to include I as well. Clear? Is this clear? Okay. Next is DP expression. So DP expression here is going to be DP of I, which is equals to, I told you guys right now, so I don't think so it's going to be a problem. You need to start your I, sorry,
Ma'am, what is that symbol? Like,
for all.
okay.
DP of I is basically maximum of whatever your previous DP stage was, DP of I minus 1, comma 0. 0 because if the previous stage is negative, then you will prefer having 0 than the negative value, plus you will add array of I to your current answer. Clear? And here your I starts from 1 and it goes till n. Where will your answer belong? As I told you, you will calculate all the answers. At the end, you have to find the maximum from the entire array, right? Entire DP array. So, okay, just a minute. First, I have to write the base condition. Base condition is nothing but here. Base condition here is DP of 0 is equals to array of 0. Your space, or sorry, your table space, here you can see you are using an entire array. and hence that makes your table size equals to n plus 1. Your time complexity here, you can see you are just traversing on your array once, so it's n. Space complexity is n, or you can say n plus 1. No, n is fine, I guess. Next is answer. Your answer is nothing but you have to find maximum of from I equals to 0 till n minus 1, and here it is array of I, sorry, dp of I. Clear, everyone? Is space optimization possible? Is space optimization possible in this question? Yes, because it is only dependent on the previous stage. So it is possible. But the thing is, at the end, you're finding the answer from all the array, right? All your DP array, you're finding the maximum from it. So in order to encounter this, wherever you are like, let's suppose wherever your DP of I was, I am maintaining a variable X. Okay, so X comma 0. So you will write here your X is equals to max of X comma 0 plus array of I. Right, this is the you will calculate, but in order to get the maximum among the entire values, you need to maintain your answer variable, which will keep calculating your max from your answer and your value X. So this will keep track of your answer. At the end, return your answer. Clear? Okay. So try to implement this particular. Even if you guys, anyone who would have implemented the DP solution so far, like Kishan was saying, he implemented, you must have noticed DP solutions are the smallest coding solutions you write. Yes, no? Yes, that's right. So is it okay for today, or do you guys want me to discuss more? Enough for today? Okay. I'm okay to close. Okay. So we will discuss like I have discussed mostly like 4 to 5 questions now on 1D DP. So there exists 2D DP as well. So now I'm going to discuss few problems on the 2D DP, and I guess then we will be good to complete our DP. Clear, everyone? Okay, perfect. So thank you for attending today's session. We will discuss more questions tomorrow. Probably I'll try to get more two to three questions on 1D DP so that I can give it to you at least as an explanation. I can explain, and then you guys can take it up from there, that you will solve it on your own. I'll try to give you 2 to 3 questions tomorrow for that, and then we'll start with the 2D DP. Clear? Okay. So thank you for attending today's class, and